So I'd like to present some techniques and lessons learned that I use to develop 3D maps that are building-centric or architecture-centric. And I'll be using this project I did a few years back in Kennecott, Alaska, part of Wrangell-St. El's National Park, where terrestrial LiDAR and architectural illustration techniques ended up being a core part of the workflow. So these are the software tools that I'll be discussing today. Just like any of the projects here, there's a million different ways to approach every project. This is the way I do it. The workflow here is generally going to be the same, independent of the tools that you use. But as a process here goes, I'm using Global Mapper. It used to be called their LiDAR module on my old version. I think it's called Global Mapper Pro here to do the actual LiDAR prep. So point cloud cleanup and conversion, any type of raster mosaicing, and then just contour creation, simplification, and export. So generally my GIS software for this type of workflow, but there's, of course, lots of other alternatives. SketchUp, and specifically SketchUp Studio for this because it allows for the import of point clouds to be able to use as your model reference. And just if you haven't used SketchUp, it's probably my all-time favorite software. I love that I can build my kitchen cabinets and a 3D geospatially referenced map in the exact same piece of software. I would live in SketchUp if I could live in SketchUp. Rendering, lots of different rendering. You know, alternative here could be Blender. You could use Unreal Engine. Lots of different things here. But I used Lumion mostly because I already have a license that was purchased years ago, and I continue to use it. And then, of course, our best friend Photoshop to clean up all the things that inevitably will go wrong or you don't want to actually do in 3D. So I've done a number of these maps over the years, all using kind of roughly this same technique. These two are relatively similar looking, but I wanted to throw in this one that I just recently completed in Santa Fe that has more of a hand-drawn, so this was hand-drawn on top, and then also my watercolor palette here. That provides kind of a different way of looking at this. So you don't end up with kind of a robotic, you know, this is what a 3D illustration should look like. So this was what the existing walking tour map of Kennecott looks like. Maybe not the artistic style that the Park Service was looking for, but this is actually a good map from a map perspective. It's like, it's clear, it's concise, you can see where to go. So in my mind, it's like, well, this is a tall order to make something that's going to be more useful than what this is. But because this is in Alaska and these are multi-hundred-year-old buildings and it's a harsh environment, a lot of these buildings are falling down in rapid states of decay. So the Park Service had done a significant terrestrial LiDAR scan of almost all of the buildings here for historic preservation. And they were also looking for opportunities to reuse this data in other ways, and it was to become an important part of this project. So for the GIS LiDAR-based prep here, just some points here. I ended up with 60 different E57 point cloud files. They ended up being about 200 gigabytes, which they were not able to upload to anything, so I had to be shipped a physical hard drive, which took a month to get to me. And so I took it to simplify and combine all these point clouds into a single file and then export this as a .lis for better interoperability, where lots of software might not do the E57. I don't have a lot of pictures from this process because I wasn't thinking about doing a presentation on this, but here's a single one of these files. I put a red dot where the base station was. One of the core problems with working with this data was 98% of the data was within a 2 to 5 meter radius around the total station. So I have a sub-centimeter accurate model of the surveyor's Gatorade bottle right next to the total station, but not the back side of the building that I'm actually looking for. So after I erased all the Gatorade bottles and rocks away from this station, I ended up reducing the data footprint by 98%, which somebody could have emailed me. So this is everything combined. So this is all 60 of those point clouds, symbolized with their RGB values, and it's cool. It's interesting to look at. It's fun to be able to explore this site in its point cloud format. You can also see the complexity both of the site and the deterioration of the structures. And then it's time to start figuring out how we're going to use this. So it's hard to see in here, but I'm starting to build some of the walls of these buildings, start to put in the windows and kind of rough in the shapes. And I took an honest pass at this and didn't get very far. So you can start to see some of the limitations here. You know, backsides of buildings don't have any detail from the perspective that we wanted to create the map from. And really from a 3D perspective, the real downfall here is you can't create planar edges because they don't exist in the real world. And this is messy to begin with. And so 3D software likes nice edges that come together at right angles, so I can add in windows and array detail and those types of things. And so it was back to go to more of a tried and true method that I've used in the past and really rely on the LiDAR more as a reference model. So very lucky here that there was great documentation. So this was a documentation done by the Historic Engineering Record, which is a part of the National Park Service. Only a few of the more prominent structures were documented in this level of detail. I also threw in this map from the report because it's really great. It has nothing to do with this workflow. And a fun connection here is all of the copper that was mined at this site was shipped down, and it's all smelted here in Tacoma. So everything came to where we're standing right now. So these are the architectural illustrations that were done by the Park Service. I think this was done in the 70s or the 80s. And this is kind of what it starts to look like. So I'll bring these into SketchUp. They're flat planes, and I'll just start to draw them out in 2D. So each wall, each side, not every building has each side represented. Sometimes I'll only get one side. Sometimes I'll get two sides, like a north and a west, or an east and a west elevation. And then I'll tilt it up, just like you're building a Walmart. And tilt up all the different sides. So here's a completed model. So this is the west bunkhouse where I have all four sides of the building. Everything's drawn, everything's in 3D, even the windows are in there. And I like to do these in their own separate files. And part of the reason I like to do that is I can keep the axes aligned. So I like X, Y, Z to be fit to the corner of a building. Once you get this in the overall model, each building is going to be turned. You can keep the axes contained to the components, but I just think this is easier. Also, I like to do this for a scale reason. All of these images that I'm bringing in for reference material are all at different scales, depending on that. So I can scale each of these models. I know that it's accurate, and I'll just build them all individually. So like I said, only a few of these were like this. The rest I had to build from photographs. So SketchUp also has another great tool that's a photo match tool that allows you to take a single photograph and also set up your axes X, Y, Z for a building, and essentially allows you to start your construction of that building around those axes. So when I isolate it here, I have my fun little 3D building. And of course, it doesn't have a backside because I don't know what that backside looks like because I don't have a photograph of it. So I have to do my best guess of what that's going to look like. And then finally for the modeling is going to be the terrain. It's interesting, they have lots of terrestrial LiDAR, no aerial LiDAR. This is actually a stereoscopic 5-meter DEM or digital surface model that was created for the site, but much too busy for the purposes here. I need a really simple terrain model. So simplified this as much as possible down to 20-foot contours to be able to export that into SketchUp. And so once again, I like things that are flat. I like things that are easy to work with. I don't know if it's obvious from here. SketchUp also has some great terrain modeling tools that are limited in the type of scale that you can use. But what I've done here is I've cut out the core corridor of where all these buildings exist and then created a series of flat planes at their accurate elevations rather than relying on topo that moves in different directions. So now I can position all the buildings how I want, I can grade them to the appropriate grades, and then I can combine it all into the actual terrain model that you see to the west and the east of this. And some of the buildings, like the little houses that you see in the blue area, you go ahead and just lay those in the terrain. They're not kind of part of the core workflow here. Blank slide for some reason. So some of these are some of the textures that I ended up creating, just clipping out of photographs. There's some steep slopes here, so there's lots of like debris and terrain. Some of these buildings are falling down. If you ever look at Google Earth and you've got a steep slope, you're going to get smearing. So a lot of this debris field was smeared, so I would take that out of a regular photograph and then basically Photoshop it into my ortho to be able to get these textures that I want. And then in the bottom there is also kind of a generic forest floor texture, because you'll see when we get into rendering, when you put 3D trees on top of 2D trees, it looks silly. So here's my edited ortho. Unfortunately, I don't have the original ortho to begin with here. But basically, I've cut out all the trees in here and replaced them with this basic texture. I've also gone in and drawn in manually the trails, the roads, given them nice buffer widths. Where there's buildings and there's lawn, I'll give them grass so that it helps separate. And this is basically something during this entire workflow that I keep running all the time. So this is always open in Photoshop. I'll be modeling something that's like, oh, I need to move this road over just a little bit. So rather than change all the geometry in the model, I'll just draw it in Photoshop and then update the texture. So super helpful to be able to work on this kind of in real time with the model itself. And here it is. Here's all my happy little buildings. So rinse and repeat on those buildings 30 to 50 times. I don't remember exactly how many there is in here, 5 minutes, with the terrain. And then this is kind of the final SketchUp step here. I have some modeling tips. I don't have time to read through them, but I'll share the presentation. So moving into rendering here, once again, reasons I'm using Lumion, it's fast and easy, has great SketchUp integration. It renders in real time, so you're not waiting 20 minutes, an hour, 5 hours for Blender to render something, even though I know Blender does have real-time rendering. And it has a robust asset library, so I don't need to go looking for the right type of Sitka spruce, species to be able to add to this. Cons, it requires a really robust graphics card. Cost, and then some of the resolution export size can be an issue for larger poster prints. Just quickly run through some of the features here. So here you can see some of the asset library, lots of conifers here, and I've circled down on the bottom. You can also scatter all sorts of assets, whether it's rocks, whether it's trees, so you can do a linear scatter, you can do a circular pattern, and you can select like 10 different species of trees. So I can pick 10 different species of conifers, or I wouldn't do 10, but say 3, and then be able to kind of randomize those on the landscape. Still have to go in and edit a lot of things manually to move them off of roads, move them off of trails. And then a lot of the final texturing is done in here as well. So I'll get some base textures in SketchUp, understand kind of what I want them to look like. But if I want like diffuse models and I want bump mapping and some of the more fancy texture stuff, I'm going to end up doing it here in Lumion. And so here is a time lapse of every single render output here. And you can kind of see the evolution of this model as trees are added, as buildings shift around, as roads type of move, even doing some manual hill shading on some of the spoils piles there. Don't know if I can start this over again. Do it one more time. But I think I came up with around 40 individual renderers over time as this kind of progressed. Get to the next slide now. All right, and here is the final product. So I didn't do any of the layout on this, so Harpers Ferry Design Center for NPS did kind of the final labeling, text layout, the actual development of the Unigrid brochure. I can't take any credit for that. And here it is in print, my final actual favorite format. And that's it. I don't know if I have any time for questions.
I think we can maybe do one question, if anyone has one. All too stunned to ask a question. We got one over there.
So thank you for that. That was wonderful. My name's Tim. I would just love to know how many person hours do you think you invested into this?
I think maybe around 200 hours probably for this project, somewhere in there.
Thank you.
Yep. And feel free to talk to me during the conference or on Slack, and I'll post the presentation. Thank you.